Right, first question about a van moving along a straight horizontal road. As with all mechanics questions, I'm just going to do a little sketch about what's going on. So its mass is 750, so that will be its weight. It's moving along a straight road, so there's going to be some sort of reaction force. When the speed of the van is v, resistance, I'm going to assume we're going that way. So my resistance is 200 plus v squared, and this is going to be my driving force. And then we've been told its rate of work, and it's moving at a constant speed, and it said we've got to show that it must be moving at 20 meters per second. Okay, so my power is 12,000. Okay, so remember that power, so our power is 12,000, is our driving force times our speed. So it said speed was v, so we know that. We can also, if I look at my diagram, we can resolve horizontally. Now the acceleration is 0, so we know the two forces must be equal in that direction, so the force is 200 plus v squared. The driving force is the resistance. We also know that from the power here, we know the driving force is 12,000 divided by v. And then I can rearrange that equation to get v cubed plus 200v minus 12,000 equals 0. And the thing is here, it says show that question. So rather than just put it in my calculator, I should show some working. Now you can put it in your calculator to find out the roots or to find out a factor, and you can find out that v subtract 20 is a factor, and then I can factorise this. So it must be v squared in order to get v cubed, and it must be plus 600 in order to get negative 12,000 on the end. And then I want 200v in the middle. So that's going to give me v cubed minus 20v squared. So that must be plus 20v in the middle. And then you can just double check that that works. Right, so what would that solve to? That gives us v equals 20. Well, that was the answer we're looking for. But what happens with this quadratic? So with this quadratic, it must, if you put it in your calculator, you'll find out that either there are no real roots or it will give you the complex roots, the imaginary roots. How do we prove that? Well, we prove that using the discriminant. So our discriminant in this case is 20 squared minus 4 times 600, and if you work that out in your calculator, for example, that's negative 2,000, so that is less than 0. So if the discriminant is less than 0, there are no real roots. So the only solution is v is 20, and we should always put a conclusion. Okay, now I did that because it wanted me to justify my answer, so rather than just put it in my calculator. If you look in the mark scheme, they did actually allow alternatives. I mean, you can use the determinant, you could complete the square, or they did, which in some cases could be seen as quite generous, allow you to state all 3 roots and then state that only v is 20 is real. So find all 3 and state. Right, then we're going on to part B. Now we've got our van is going up a road that is inclined at an angle. So let's have a new diagram. Okay, and the resistance, exactly the same as before. Okay, and now it's working at a rate of 15,000 watts. And we want to find the acceleration when v equals 10. Right, so if v equals 10, we can work out what the resistance is. So that's now 300. We can also work out, we know V is 10, and we know power is our driving force times our speed. So we can work out our driving force. Right. What we can do then, now we can resolve parallel to the plane, and we're going to have to use force is mass times acceleration because we're trying to find the acceleration. So going up the plane, we've got our driving force. We then, acting in the opposite direction, we've got resistance, and we mustn't forget we're also going to have a component of the weight. So you can split your weight into the two components. So we're looking at the one acting parallel to the plane. If you work through your angles, this angle is also theta there, and that means I want to resolve on the opposite side to theta. So this is going to be 7,050 sine theta. So that's my force, my mass, 750. My acceleration. Remember, you're given what sine theta is, it's 1 over 15, so you can sub that straight in, and if you then rearrange, you can get the acceleration is 71 over 75, which is 0.95 meters per second. I've rounded to two significant figures because in the question we would have used G as 9.8, so that's only that's rounded to two significant figures, so I've rounded my final answer to two significant figures.